Now at this point, I need to take a little aside and make sure you guys remember something from your high school chemistry class. And also, I'll just tell you, we're going to talk a little bit more about aqueous solutions in the next unit. But now there's something important that I need to tell you. And that is, remember, the state symbol AQ indicates that particular substance is dissolved in water. Okay? AQ indicates dissolved in water. And the other thing you have to remember is if that something that's dissolved in water is an ionic compound, that means that an ionic compound, when it dissolves, it separates into its ions. And the ions are what we call mobile, or that you have a mobile charge in solution. And that's very, very important in a lot of different situations in chemistry. And so what we'll see sometimes, here, let me just show you what I'm talking about for a second. If you have, for example, let's see here, if you have sodium chloride solid, the state symbol is solid, then what you recognize is that that particular compound is in its solid form. And for sodium chloride, and for all ionic compounds, you have a three-dimensional crystal of sodium ions surrounded by chloride ions, surrounded by sodium ions, surrounded by chloride ions, in a 1-to-1 ratio of the ions. That's what that formula unit is telling us, okay? And so it's this big crystal. Well, not necessarily big, but it is a crystal. And you have sodium ions and chloride ions surrounding each other, all right? Whenever you see this, sodium chloride aqueous, the AQ is telling you that that particular compound, and in this case it's an ionic compound, is dissolved in water. And when it's dissolved in water, what you should be thinking is that sodium and chloride are no longer fixed in positions in a crystal, but rather when you plunk that crystal into water, what immediately starts happening to that crystal is that the sodium and the chloride ions on the surface of the crystal, as it works down and it dissolves, are sort of pulled into solution and are floating around in solution surrounded by water molecules. And we'll get into this a bit later when we talk more about water. But for now, I need you to know that what the chemist knows and what they think and what they see when they see an ionic compound with AQ next to it, they know it's dissolved in water and that it's not existing as you know, pairs of sodium and chloride ions, but the sodium ions and the chlorides are free, moving around, mobile, moving around, you know, surrounded by water everywhere in solution. Okay, so that's a real important concept. And the reason why, and to emphasize this, I need to tell you that a lot of times we write redox reactions in terms of the ionic or net ionic reaction, because the reason why they do that is because they're just emphasizing what's participating in the redox reaction. And so sometimes certain species do not participate in oxidation reduction, as we have seen. And so in that case, a lot of times they're left out of the redox reaction. And I don't want that kind of way of writing things down to confuse you. So let's take another look at a previous example. And I'm going to review with you very quickly how we would represent this particular example that we've already looked at in terms of just showing it as the ions, what we call the ionic reaction or the net ionic reaction. Okay, and so what you do, we've already recognized, you know, what's undergoing reduction and what's undergoing what's undergoing oxidation and what's undergoing reduction here. And previously, we've noted all of the oxidation numbers. Now take a closer look here. The sodium bromide is aqueous, so it's dissolved. So if I want to write it like how the chemist really thinks about it, I would recognize that these ions are separated in solution. So I have 2 sodium ions in solution plus 2 bromide ions in solution. That's what the AQ tells us. Plus the chlorine gas bubbling around in that solution. Plus, but it's still in the form of the gas, plus 2 sodium ions floating around. Plus 2 chloride ions floating around. Plus now some bromine liquid that has been formed across the reaction. All right, so this is all aqueous, 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 aqueous. They're all floating around. And now you take a step back and you look at this reaction like, hey, you know, what's changing here is the bromide ion is going to bromine, elemental bromine, whoops, 2, and the chlorine gas is going to chloride ion, okay? And the sodium is not changing. So the species that don't change, those are just called spectator ions. And a lot of times what people will do is they'll write the net equation down, they'll leave off the spectator ions, it's the exact same thing on both sides, and they'll focus on what's really important in this reaction, which is what's changing. Okay? And when you write it like this is called the net ionic equation. We can very easily see how the oxidation numbers have changed and what's undergoing oxidation and what's undergoing reduction. So a lot of times you'll see redox reactions written this way, and it's just kind of by convention because it's what you're focusing on. Okay? Now look at this one again. This is the example we did on the last page where we noticed in this case that there was no change in oxidation state across this particular chemical change. And so in this case, remember, if we see aqueous, aqueous, solid, aqueous, aqueous, what we want to do is write it down, and it's a sodium ion floating around in water, plus a chloride ion floating around in water, plus a silver ion floating around in water, plus a nitrate anion floating around in water. And on the other side, you have AgCl. That's the solid. And then the other salt is the sodium aqueous plus also floating around in water, sodium and nitrates. Okay, and what you see here is the what has not changed. Sodium is the same on both sides. Nitrate is the same on both sides. Those are all spectator ions. What has changed here is the silver chloride ions come together to form silver chloride solid. All right, you got your ions floating around. This is called, again, the net ionic equation. This is what we call a precipitation reaction, but there's no transfer of electrons.